Welcome, class. Today we are going to wrap up our discussion of Chapter 7 by looking at one other specific type of reaction, and these are called oxidation reduction reactions, or sometimes abbreviated as redox reactions. And these are reactions involving the transfer of electrons. So all we're going to remember is all of these will involve movement of electrons from one species to another. Now, the name comes from the processes that are involved, and so as we go through this, we'll look at what we mean when we say oxidation and reduction. Now, why do we look at these reactions? Well, we're not really going to dive in detail into analysis of them like we did with precipitation reactions. We're going to look at more how do we identify them based on, just looking at them. But the reason we look at them is because they're responsible for a lot of reactions that we encounter. So, for example, rusting of iron, right? Or, for that matter, any kind of metal corrosion, really, is going to be a type of redox reaction. Hair bleaching, or bleaching of clothes. Production of electricity in batteries, right? Combustion of gasoline, right? Essentially the burning of anything, right? These are all examples of redox reactions. So they're important reactions in our everyday lives. Now, many of these redox reactions involve reaction with oxygen. And so some of the ways we'll identify this is to look for the presence of oxygen. So, two processes involved in these types of reactions. We have oxidation. Now, oxidation, right, is the loss of electrons. And that's paired with a reduction, or the gaining of electrons, right? So I said these are reactions that involve a transfer of electrons. So in order for an electron to be transferred, something has to lose those electrons or undergo oxidation, and something else has to gain those electrons or undergo reduction. Now, if you're trying to remember how to keep this straight, oxidation goes with loss, reduction goes with gain. If they help you, there's a couple mnemonics that are listed in the book that are often used to help people remember these. We have oil rig, which stands for oxidation is loss, reduction is gain. That's one that works for a lot of people. We have Leo Gur, or the longer version, a Leo the lion says Gur, where lose electrons oxidation, gain electrons reduction. So a couple of maybe helpful ways to keep these two terms straight. Okay, so we have oxidation and we have reduction going on here. Now, a couple things about these processes. They have to occur together, right? They occur at the same time, right? Once the electrons are lost, they're gained by something. They don't just float around looking for someplace to go, right? If they're lost, they're going someplace, right? They have a destination, so they occur simultaneously together. But as I said, we're not going to have to sort of go in and delve into where the electrons are coming from, where they're going. Save that for a chapter on later in the semester. But for now, we're just going to try to identify a redox reaction by looking at it. So we'll look for visual signs when we see a reaction to identify it as a redox reaction. So we can kind of look at 4 categories, if you will. So the first one involves a substance reacting with elemental ion. Now, oxygen. So this falls into 2 categories, right? We could have a metal reacting with elemental oxygen. So I'm going to write that here. So for example, we might have the reaction of magnesium metal plus O2 gas forms magnesium oxide. solid, right? So a metal and a metal combines with oxygen to give you an ionic compound, right? As our product. Now, the other version of this is when the substance is not a metal, but it's a non-metal or a molecular material, and we're going to cover that when we look at combustion reactions on the next slide. So we'll come back to that. We could also have a metal reacting with another non-metal that's not oxygen. So for example, we could have calcium metal reacting with, say, Cl2 gas to give you an ionic compound again, to give you calcium chloride. Now, both of these fall under a general category that's called a combination reaction. So, as we've gone through, we saw that precipitation was a double displacement type reaction. These are combination reactions. And at the end of the talk today, we'll talk about these different categories of reactions. Now, we could also more generally have a reaction where we can see that a material is losing or gaining electrons. Now, how can we see this? So let's look, for example, we have this reaction. We have zinc metal plus a solution of copper chloride forms a solution of zinc chloride plus copper metal. Now, if we look at this, we see that we have a metal that turns into metal ions, right? So here we have zinc metal turning into zinc ions as part of this ionic compound, right? Zinc 2+ ions. We have copper ions as part of this ionic compound, copper chloride, that are turning into a metal, right? So when we see this transition from an elemental metal into metal ions, or metal ions into an elemental metal, we have to have the flow of electrons going on. So when you see a reaction like this, we can classify it as a redox reaction. So when we have the formation of ions, right, that means we're moving electrons around. And so the last type of redox reactions that we want to be able to identify again are these combustion reactions. So they also involve a reaction with elemental oxygens, but instead of being a metal, it's a molecular compound interacting with oxygen. So combustion reactions are reaction of a substance. Now, more specifically, right, this is going to be a molecular substance, right, to form one or more oxygen-containing compounds. So these reactions are characterized by exothermic, right? These are what we commonly know as burning reactions, right? These are what we call combustion. Now, these are really nice because they're really easy to identify. So the key is to look for a molecular compound, again, often containing carbon and hydrogen, sometimes oxygen, reacting with elemental oxygen to form oxygen-containing compounds, right? Even more specifically, they will always form carbon dioxide and water. Okay? So if we have a carbon and hydrogen containing compound reacting with oxygen, you're going to always form carbon dioxide and water. And so if you see a reaction that fits this profile, right, where we have a molecular compound reacting with oxygen to give you CO2 and water, then we can immediately identify it as a combustion reaction and therefore a redox reaction. So I want to close out the chapter by looking at what we've been talking about as these classifications. So when we classify reactions, we can put them into 4 big categories that most reactions will fit into. We have what are called synthesis, or more commonly combination reactions, which we saw a couple examples of, where we have 2 things or more than, or 2 or 3 things becoming one, right? So we are combining things, so we end up with less species. We have decomposition, which is just the opposite. We have one material, or sometimes 2 materials, breaking down into other materials, right? So we have a breakdown of materials. We have single displacements, right? We saw this with the 3rd type of redox reaction, where we had the zinc metal reacting with the copper chloride, right? Where we have an element reacting with a compound where the element replaces one of the elements in the compound. So in this case, A is replacing B. In the example that we had, the zinc replaced the copper. So that's a single displacement. And then we have double displacements, and this is what we saw in our precipitation reactions, where we have this swapping of ions, right? So A goes with D, B goes with C to make our potential products. So combination, decomposition, single displacement, double displacement. So we can look at a couple examples of this, right? So combination or synthesis, right? Basically, we take 2 things to make one. Sometimes it's 3 things to make one. Could be, I suppose, we have 3 things to make 2 things. There's some different variations, but most commonly you'll see this kind of process here. We have decomposition, so this is the breakdown from a compound into its elements, or a compound into simpler compounds sometimes. And then lastly, we can look at an example of single displacement that we saw, where one element is replacing another one or displacing another one in a compound. And then of course we have the double displacement reactions, what we saw when we looked at precipitation reactions, where the ions in these ionic materials are swapping places. So there we have classification of chemical equations or chemical reactions. So in this chapter, again, we've looked at some of the basic ideas of chemical reactions, how to write them as chemical equations, how to balance those, and we've looked at a couple specific types of reactions that we want to be able to work with, precipitation and redox reactions. In the next chapter, chapter 8, we're going to look at more how to work with these chemical equations in a quantitative way.